everyone, we're going to find the limit using L'Hopital's rule. We have the limit as x approaches 0 from the right of 1 plus 1 divided by x, all to the power of x. So let's see what form we have. If we plug in 0, we're going to get 1 plus, this is the limit's going to be infinity, and then this is going to be to the 0 power. So basically 1 plus infinity is just infinity. So we have the indeterminate form, infinity to the power of 0. So what we're going to do is use this formula here and write our f of x equal 1 plus 1 divided by x to the power of x. And then we're going to take the natural log of both sides of the equation. And I'll put the x in front already. So ln of 1 plus 1 divided by x. All right. Now to write it in a form so we can use our L'Hopital's rule, we're going to write this as ln of 1 plus 1 divided by x. And then rewrite this as 1 divided by x. These two expressions are equivalent. Now let's take the limit, and what we're going to find is this limit here. So we're taking the limit as x approaches 0 from the right of ln of f of x. Okay, well, eventually what we're going to need to know is the limit as x approaches 0 of f of x. So that's why this formula is going to help us out. So we're going to do the limit as x approaches 0 of ln of f of x, which is going to be ln of 1 plus 1 divided by x divided by 1 divided by x. Now I can use L'Hopital's rule. And keep in mind, I want to write what this is. If I get the common denominator, I'm just going to think about this. This is just going to be x plus 1 divided by x. So let's use L'Hopital's rule. And as we take our limit of x approaching 0 from the right, we differentiate the numerator. That's going to be 1 divided by this quantity, which is this. So I'm going to write that. X plus 1 divided by x times the derivative of our inner function. So that's just going to be the derivative of 1 divided by x, which is going to be negative 1 divided by x squared. And then we have the derivative of a denominator, which is also negative 1 divided by x squared. So simplifying this cancels out. And we're going to have the limit as x approaches 0 from the right. And I'm going to flip this x up here. We're going to have x divided by x plus 1. So let's apply the limit. You plug in 0, we're going to get 0 divided by 1, which equals 0. So that's what the limit of ln of x is. So this here equals 0. All right, but we really need just the limit of f of x, so we're going to use this formula. Therefore, we have the limit as x approaches 0 from the right of our f of x. This is your f of x equals the limit as x approaches 0 from the right of e to the power of ln of f of x. So the reason they write this formula like this is because if you have e to the power of ln of a, that just equals a. So we're really looking is for this. And so we can evaluate this finally and write this as e to the power of ln of f of x. That was 0. The limit of ln of f of x was 0. So e to the 0 power equals 1. And that is your final answer. Thank you. Have a nice day. Bye-bye.